Hello my dear students, welcome back to NEET World. So we are discussing IPE questions, right? So I hope you are following our sessions that we have completed all the LAQs related to IPE class 12th chemistry as well as SAQs from few chapters, okay? And today we will be discussing polymers chapter. What is that? Polymers for 4 marks, okay? So from these polymers you can expect either 4 marks question or 2 marks question from here, okay? So let us first of all complete SAQs, that is 4 marks questions from this polymers chapter, okay? So look at this is our C60 material. So this C60 material is designed to score 60 out of 60 in your IPE exams, okay? Whether you are from Telangana or AP students, AP states, so you can both of you can follow this material for chemistry as well as we have for physics and mathematics for MPC and biology for BPC students, okay? Now all these materials can be accessible for every students of Telangana states and AP, Telugu states both, okay? Now how can you access these materials? It's very easy. So just go to Play Store and download NEET World app, okay? Download NEET World app. So in this NEET World app, once after logging it, so you just say hi in the chat box, okay? Or otherwise mention booklets, IPE booklets in the chat box, then our team will guide you how to access this, because yes, there is specific things to be opened there, that's why our team will guide you once after going into app, okay? So that's it, okay? This is how you can access all the IPE materials whether you are MPC, BPC students of both Telangana and AP states, okay? Right. So let us discuss these things. So just once look into this thing, like these many chapters are there, yes, long answer type questions are done. So in this we have completed most of the topics, like here I have covered P block elements as well as D and F block, then next here and here all these 3 are completed, yeah, right. Remaining today we will be discussing about polymer chemistry. What we are discussing? Polymers we are discussing, yes, it's very small topics. It's very small topic, I will finish it now, okay? Then later we will be moving for other chapters also, okay? So just stay connected and use all the live sessions we are conducting for both first year and second year, and you can share these sessions with your juniors or whoever your friends preparing for IPE exams, whether they are class 11th or class 12th, okay? Right. Let me show you this. Guys, one more thing, once accessing these materials, you just open whatever the content there in the material, I will be explaining here. It means you will feel more comfortable when you see same explanation from the book. This is what you need to go and attempt in the exam also. Yes, so look at this is our polymers. If you open the booklet once after downloading the PDF, you will be seeing polymers like this. Now what is the first question in the book? So just look at here, write the names and structures of monomers used for getting following polymers. So for getting this polyvinyl chloride, in the short form we are calling it as PVC, right? So how do we get PVC? What is a monomer unit? Teflon, okay? So where do we use this Teflon? See, we will be using non-stick pans, right? So on that we will be seeing some black coated things. So that coating is nothing but Teflon, okay? Previously it is used to be coating for pans, for the dosa pans we will be seeing now. Yes, the next, bakelite. So bakelite is a polymer of formaldehyde. I will explain you about that clearly here mentioned, okay? So where do we use bakelite? So we will be using that in the switches, making of switches, we will be using this bakelite, okay? So the next, polystyrene, okay? So what do we mean by styrene here? Everything I will explain. See here, see, polyvinyl chloride, in the short form let us say it as a PVC. So polyvinyl chloride, it is also called as PVC, okay? So now what is a monomer unit? See, polyvinyl. So vinyl chloride is a monomer unit. See, vinyl chloride is a monomer unit. So poly, taking n number of such units, we will get a polyvinyl chloride. See, what is the structure of vinyl chloride here? See, I am writing here, write as it is, CH2 double bond CH chlorine, that's it. This is a vinyl chloride. What is the name of this compound? It is vinyl chloride. So you can write vinyl chloride, okay? So just take n number of these monomeric units, okay? It means lot of monomeric units combined to give you PVC, polyvinyl chloride, that's it. This is what you need to mention in the exam, that's it. Next one, Teflon. So what is this Teflon? See, Teflon, the monomeric unit of Teflon is tetrafluoroethene, okay? it means see, ethene means you are writing C double bond C, right? So on 2 carbon atoms you write 2 fluorines like this, F, F, F and F, that's it, that's it. This is tetrafluoroethene, okay? So you take n monomeric units of such kind, okay? So upon polymerization we will get tetrafluoroethene, polytetrafluoroethene. So here you can see PTFE, it means what? Polytetrafluoroethene, okay, polytetrafluoroethene. So this is the name of this compound, okay? See why we are calling it as tetrafluoroethane. See, this is an ethene, like we know C double bond C, H2 means we are saying it as ethene right now. So all these hydrogens are replaced by fluorine now. So we need to specify the names. What are the groups? Here we have fluorines, right? How many are there? 4. So tetrafluoroethene is a monomeric unit, okay? Upon polymerization we will get polytetrafluoroethene, that's it. That is the Teflon, okay, right. This is clear now, whatever we discussed till now. Is this clear or not? Right, let me explain. After this, just look at here. They are saying bakelite. What do we mean by bakelite? So bakelite is a polymer of phenol plus formaldehyde. What are the monomeric units here? You need to take phenol plus formaldehyde. What is the structure of formaldehyde? C double bond O, H and H. It's an aldehyde group. So polymer of this combination, these 2 monomeric units polymerizes to give you a product. That product is called as a bakelite. What is it called? Bakelite, okay? So they are not asking the structures of bakelite, I mean polymers, they are asking about monomers and their structures, monomers and what are the monomers to get these polymers, that's it, okay? The next, what about polystyrene? See, here I have mentioned only formaldehyde, add phenol also, phenol plus formaldehyde polymer is called, we can say bakelite, okay? Now what about here polystyrene? So what is the structure of styrene? It's very simple. See, styrene means you write this benzene ring, okay? On this you insert CH double bond CH2, okay? So just simple, it's very simple. See what I am doing here, just try to remember, you know ethene, right? So write ethene first, CH2 double bond CH2, okay? Out of these 2 hydrogens on 1 carbon, just replace that hydrogen on 1 carbon with 1 phenyl ring, that's it, like this. So this is called styrene. What is it called? Styrene, okay? So styrene upon polymerization gives polystyrene, okay? That's it. First question is done, okay? The next one, second question, you can see, explain the difference between natural rubber and a synthetic rubber. It is also very easy, look at here. So natural rubber is nothing but it's a polymer. See, natural rubber is a linear polymer of isoprene. What do we mean by isoprene? See, first question is done, I am erasing this. Second question will explain what is mean by natural rubber. Say it's a linear polymer of isoprene unit. What do we mean by isoprene? See here. So what I am taking, look at here. See, it is mentioned as isoprene. What do we mean by isoprene? 2-methyl 1,3 butadiene. See, 1,3, see 1, 2, 3, 4. So how many carbons are there in the parent chain? 4 now. So you can say but, okay? And double bonds are there. How many are there? 2, diene. And at second position what we have? Methyl group. So 2-methyl 1,3 butadiene. What is the name of this isoprene? The IUPAC name, isoprene IUPAC name is very important even if you are preparing for EAP set, JEE, NEET also. So it is 2-methyl 1,3 butadiene is a IUPAC name of isoprene. So what is the use of isoprene? Yes, isoprene is the monomeric unit of natural rubber. What I am saying? Natural rubber monomer unit is what? Isoprene, that's it. So listen here. So natural rubber is a linear polymer of isoprene called as 1,4 polyisoprene. Which one it is? Cis polyisoprene is called our natural rubber. Okay. what I am saying, cis polyisoprene is called our natural rubber. So what do we mean by cis polyisoprene? See here what I am writing, this carbon I am writing here CH2, okay, again here this side CH3, here this CH3 and this double bond here, and I am writing here CH2, like this we have now. So when it is shifting here, this chain will be like this, and here if you see, one minute, yes, so like this, if you see this chain, how you are seeing, so what you are seeing here, what do we mean by cis and trans? Cis and trans means, for example, I will take one simple example, see here, H and H, here I am writing CH3 and here also CH3. See, if the same groups on the double bonded carbons, if the same groups are on same side, you should say it as cis. See, methyl group same side now, cis. If one methyl is down and another methyl at another carbon on opposite side, like 180 degrees to each other, you should say trans now. So in the similar manner, if you see this polymer chain is extending this side, again to the same side of the other carbon also extending same side, like down side only now. So it means you should call it as a cis one. What is that? Cis. Okay. So cis polyisoprene is called natural rubber. So what is that? Cis polyisoprene is called natural rubber. Okay. Sir, why you are specifying only cis polyisoprene? What about trans polyisoprene? Yes, the trans polyisoprene is called gutta parcha. That is not our discussion here. What we are discussing only about cis polyisoprene. So how do we get this cis polyisoprene? See, natural rubber is a linear polymer of isoprene. So when you take isoprene, this is the structure of isoprene. Upon polymerization gives 1,4 polyisoprene, cis 1,4 polyisoprene. So this is called particularly cis one only called as a natural rubber, not trans one. Remember, okay, only cis isomer is called cis polyisoprene only called as natural rubber, not trans polyisoprene. Okay, remember. The next, it is a homopolymer. Yes, why we are saying it as a homopolymer? Homopolymer means it is made up of only one monomeric unit, I mean one type of monomeric unit. See, all is complete polymer of this natural rubber polymer we are taking now, it is only made up of isoprene unit only, no other constituent part is there, only it contains only one component part multiple times. That is what isoprene is the only monomeric unit used to make this polymer. That's why we are calling it as homopolymer. Okay, next, you can see here it is obtained from latex of natural, latex of rubber trees. It means it is a natural one, the monomer unit whatever you are taking here. So this polymer we are getting now, so it is obtained from latex of rubber trees. It is naturally obtaining from where? Rubber trees. Okay, and polymer length is not uniform. Okay, polymer length is not uniform. Which one? Natural rubber polymer length is not uniform. It has low fixing quality. Okay, it has very low fixing quality. When you compare with synthetic rubbers, synthetic rubbers are either homopolymers or it can be copolymers also. Copolymers means what? It can be combination of two or more other monomeric units. Okay, here only one monomeric unit we are taking now, but here it can be two or more types. Okay, see, it can be homopolymer, yes sir, or it can be copolymer of 1,3 butadiene. What is that monomeric unit here? 1,3 butadiene. Okay, right, 1,3 butadiene and its derivative. Okay, so now like we have buna S, buna N, like that, those are some examples here. It is prepared from chemicals. How it is prepared? So synthetic rubber is prepared synthetically in the laboratory, you can say. That's why it is mentioned as it is prepared from chemicals. Okay, now it may be a homopolymer or it can be a copolymer. Which one? Synthetic rubber can be a homopolymer or it can be a copolymer also. Okay, polymer chain length is uniform here. So synthetic rubber polymer chain length is uniform, whereas here not uniform. Next, it has high fixing quality. Which one is having high fixing quality? Synthetic rubber is having high fixing quality when you compare with the natural rubber. Okay, that's it. Now, what is natural rubber? How does it exhibit elastic properties? So just read this statement once, what they are saying. So natural rubber is a linear polymer. Already we have written these points here now. So same points repeating here. See, what is a natural rubber? So it means whatever you studied here you can express here. Okay, how does it exhibits elastic properties? This extra point we need to write now. See, so natural rubber is a linear polymer of isoprene, that is 2-methyl 1,3 butadiene is also called as cis 1,4 polyisoprene, cis 1,4 polyisoprene. It is obtained from latex. From where it can be obtained? It is obtained from latex of rubber. Okay, a colloidal dispersion of rubber in water. So where it is obtained from? It is obtained from latex of rubber trees. Okay, so rubber trees, what exactly it is? It's a colloidal dispersion of rubber in water. Okay, so it means during extraction of this rubber we need to remove that water, like coagulation, means we need to remove water, and everything like purification we need to do now. So that time you need to remove water from this and we need to extract rubber from this colloidal dispersion of rubber in water. Okay, then next, natural rubber is an elastomer. What they are saying? Natural rubber is an elastomer. So each cis polyisoprene chain is held together by weak van der Waals forces giving a coiled structure. So what is the reason here? So each these chains are there now, these long chains will be there now. So these long chains are like, those are nothing but each cis polyisoprene chain held by weak van der Waals forces between the chain. This is one chain and another chain, like that we have now. So between the chains what they have? Weak van der Waals forces are present. Okay, due to this reason, this whatever the polymers we are seeing, this cis polyisoprene units we are seeing, they will be having now coiled like structure. How it will be? Coiled like structure, like a rings you can say. Okay, like whatever the rubber you are observing, yes, how it will be? It will be very coiled shape now, right? So what is the reason for that? Cis polyisoprene chain is held together by weak van der Waals forces. Okay, so when it is stitched, chains uncoil. So what happens when we are stitching the rubber? It will be going from uncoiled form to coiled form to uncoiled form. It means it is arranged like a straight chain now. Okay, so chain uncoil, on release they will coil back, showing elasticity. What do we mean by elasticity? When you stretch a rubber, what happens? Previously it will be like circles, I mean like a round like this we will be having. When you stretch it like this, what happens? This coiled form will become uncoiled form right now. So whatever this round forms we are writing, that is called as coiled forms right now. So when you stretch it, what happens? It will become uncoiled form. That's it. That is what they are explaining. When stretched, chains uncoil and again releasing it back, it will back. What happens? It coils back. Okay, so this shows elasticity. What it explains? It shows elasticity. That's it. Okay, this is the question. The next one here we have one last question from polymer chemistry. The question says, what are LDP and HDP? How do they formed? Okay, so what they are asking, what are LDP and HDP, how do they formed? Very easy, look at here. See, LDP means low density polymer. What I am saying? Low density polymer. LDP means low density polymer. Obtained by polymerization of ethene. Okay, how it is obtained? Obtained by polymerization of ethene at 1000 to 200 atm pressure. It means high pressure is required and temperature is 350 to 570 Kelvin. Okay guys, see this is IPE questions now. You need to max whatever the information they provided in the textbook, I mean in the material. Okay, please try to remember it, try to explain, like write or represent these numbers as it is to get a good marks, because examiner will check only what exactly present in the main book. He will compare with that. Okay, so look at here. See, LDP obtained by polymerization of ethene at 1000 to 2000 atm pressure and 350 to 570 Kelvin temperature in presence of a catalyst. What? In presence of a catalyst. Okay, now you can see here structure is branched and flexible. So low density polymer will be having branched structure and as well as it is flexible. Okay, it is flexible, used for insulation of wires, squeeze bottles and toys. Where it is used? LDP is used for insulation of wires. Okay, this electric wires are there now. So on that For insulation purpose, this LDP is used, low density polymers are used. See, why do they having low density? Because let us say these are the normal chains. If this is a normal chains, they will be closely packed now. So they will be closely packed means their density becomes high. So that will be the scenario in high density polymer. But when they say about low density polymers, it means it has lower density. What is the formula of density? Like mass by volume we know. Okay, it means if volume is greater, for this volume is greater, then what happens to density? Density is small, right? Density is less. So it will be in case of low density polymers, they will be having branches. So due to these branches, see, branches means this is one chain, it will be having one branch like this. Okay, like this. So this is also having branch like this. So due to the presence of these branches, what happens if this is one layer having branches? So now this branch will not allow the down chain to come closer. So due to that, they will occupy more space. If they are occupying more space, more volume is occupied, so they will be having lesser density. That's it. That is why we are calling it as low density polymer. So this is how you can understand it easily. Okay, so you can see here they mention it is structure is branched. So due to its branches, the polymer is becoming low dense. Okay, then next here you can see high density polymer. You can see here high density polyethylene, HDPE, LDPE we will be studying now. So these are nothing but here formed by polymerization of ethene. So you can write it as HDPE, that is LDPE also. Okay, so it is a polymerization, it is formed by polymerization of ethene using Ziegler-Natta catalyst. Okay, remember this. What is the catalyst used? Ziegler-Natta catalyst, and you need to write its chemical formula also. I will explain. Wait. Okay, at low pressure. So what is the pressure here used? 2 to 4 atm pressure and 333 to 343 Kelvin pressure, Kelvin temperature. So 2 to 4 atms pressure and 333 to 343 Kelvin temperature. These are the things to be maintained. Okay, structure is linear and closely packed. How it is packed? It is very closely. So it is linear. So it's like a chains only, like this. Okay, so when it is like this, there is no chains. See, it's a linear. There is no branches here. Okay, they won't mention about branches here. They specifically mention branches. Okay, so since there is no branches, what happens? These chains will become closer to each other. Therefore, they will be packed very closely. So when they packed very closely, they will occupy low volume and have more density. So low volume means high density, right? Right. So that's why high density polymers we are seeing. Okay, so structure is linear and closely packed, used for pipes, buckets, milk cans. What they will be used for making pipes, buckets, and as well as milk cans. Okay, which one? High density polymers, polyethylene is used. Okay, whereas low density polyethylene is used for making wires, squeeze bottles, and next toys. Okay, that's it. So this is about 4 marks questions of our polymers chapter. Okay, and in the upcoming sessions we will be studying the remaining topics, remaining chapters, like every chemistry in everyday life is a surface chemistry is one of the important topic. Okay, as well as solid state is also there. Yes, we need to complete these chapters also, and along with that we have few 2 marks questions to be discussed. Okay, we will be covering all of those in the upcoming sessions. So just stay connected with this NEET World YouTube channel, and you can make your preparation more productive, even if it is IPE, JEE, NEET or EAP set. Okay, just click on the subscribe button, just stay connected with us, and you can also share with your friends who are preparing for IPE, as well as once after completing this, yes, I hope you will be also preparing for JEE, NEET or even EAP set, right? So already we are conducting free live sessions for EAP set also. You can watch those sessions and make your preparation more effective and more productive. Thanks for watching. Stay connected. Thank you.